Yeah, in this video I'm going to teach about the capacitance concept completely. The capacitance concept is very useful for various competitive exams, that is like ALP technicians and junior engineer exams. So most of you know very few things about capacitance. I have collected all the things about capacitance I am presenting in this video. And please subscribe for electrical learning track such that you can get alerts when the videos has been posted. So welcoming to the subject, the capacitance. So in this presentation I am going to teach you various concepts on capacitance, that is basic concept of capacitance, factors affecting capacitance, capacitance with different mediums, that may be air medium or the other dielectrics, different dielectrics, and types of capacitors, various types of capacitors, and capacitance coding and objective bits on this concept. So these are the various things I am going to discuss in this video. If you watch this video completely, you will be able to answer the bits asked on capacitance in the competitive exams like JE and ALP technicians. So we'll get into the subject. So introduction to the capacitance. What is capacitance? Capacitance is constructed for the purpose of storing electrical charge. That is the main purpose of construction of capacitance. So before going to know about the capacitance, why the capacitance is constructed? The capacitance is constructed for the purpose of storing electrical charge. So the capacity of store energy depends on the constructional details of the capacitance. So what are those constructional details? We will discuss later. The capacity of storing energy depends on the construction of the capacitance. So while coming to the capacitance, basic concept of the capacitance, the definition is the two charged plates separated by an insulating media is called capacitor. So two charged or conducting plates separated by an insulating media is called capacitor. What is insulating media? That is insulating one, that may be air, that may be insulate, that is other dielectric materials like mica, paper, like different insulating materials. So when two conducting plates separated by an insulating media, that is charged plates, is called capacitance. So the capacity of storing energy of capacitor is called capacitance. Okay, so capacity is when two charged plates separated by an insulating media is called capacitor. The capacity of storing energy of capacitor is called capacitance. We already stated that the capacitance is built for storing energy. So the capacity of storing energy of capacitor is called capacitance, that is given by charge per unit potential difference. So charge on the plates by potential difference across the plates, that is capacitance of the capacitor. According to the capacitance value, the capacity of storing energy of the capacitor is there. The units for capacitance is farads or coulombs per volts. Both are same. So units are farads, mostly accepted. And where C is capacitance of the capacitor and Q is charge on plates. So we have to remember that one charge on plates, the charge on the plates is on both the plates is same. But one has positive polarity and another has negative polarity, but the magnitude of the charge on each plate is same. We have to remember that point. And V, potential difference between the conductors. So this is about capacitance basic definition. Okay, so now while coming to the get into the concept in detail. So capacitance of parallel plate when medium is uniform. Okay, we have two plates, charged plates, one is plus Q and one has negative charge minus Q. It is separated by a medium, insulating medium. Okay, it has a permittivity of free space E0 and relative permeability ER. and A is area of the charged plates, and V is, okay, potential difference between the plates, and D is thickness of the insulating medium. Then the capacitance value is given by E naught ER A by D. E naught ER A by D. Now, so when capacitance of the parallel plate, when medium is not non-uniform, what is that? When two charged plates are there, in between different medium of dielectrics used, if different medium of dielectrics used. So one dielectric has relative permeability ER1, another dielectric has relative permeability ER2 of thickness D2, and a third dielectric has relative permeability ER3 and thickness D3. Then the capacitance value is given by epsilon naught A by D1 by ER1 plus D2 by ER2 plus D3 by ER3 farads. So according to the dielectric material medium used, the relative permeability value will be changed. So according to that value, so the capacitance value is going to be changed. According to the conducting plates area also, capacitance is going to be changed. So A equal to area of the charged plates, and D1, D2, D3 are thickness of the mediums, and E naught is permittivity of dielectric material of free space, that is 8 into 8.54 into 10 to the power of minus 12 for free space, and ER equal to relative permittivity, that equal to 1 for air, and if the material dielectric material used is mica, and ER equal to 6. If the paper is used, ER value will be some different value. So for each dielectric material used between the plates, the ER value will be changed. According to that, capacitance value will be changed. So now we are coming to that. So when two charged plates are there, so in that some part has a dielectric material used of thickness T, and other part is air medium is there. So now what is the capacitance value? So we have to find now capacitance value equal to E naught A by, and what is the value? Thickness for the dielectric material is T, then T by, and its relative permittivity is ER2, then T by ER2. And what is the total thickness of the insulating material? Whatever may be the different insulation, that may be air, that may be dielectric material. So total insulating thickness is D. Now air thickness is D minus T. And what is the relative permittivity for air? That equal to 1. That is the capacitance value for when the dielectric insulating material used is two different mediums. One is air and another one is dielectric material used in the case of in place of a insulators. Okay, between the conducting plates. So according to the thickness values and according to the relative permittivity values, capacitance will be changed. Okay, so when two charged plates are there, another case, if two charged plates are there, so the medium between them is air. Dielectric material, what is the insulating material is air. If we introduce a dielectric slab in between these two, what is that? If we introduce a dielectric slab, that is some kind of dielectric material other than air medium, we have introduced in between the medium of air between the conducting plates, then what will happen to the capacitance value? So suppose total thickness of the insulated medium is D, and the dielectric slab thickness, let it is T, and its two charged plates are there. Another case, if two charged plates are there, so the medium between them is air. Dielectric material, what is the insulating material is air. If we introduce a dielectric slab in between these two, what is that? If we introduce a dielectric slab, that is some kind of dielectric material other than air medium, we have introduced in between the medium of air between the conducting plates, then what will happen to the capacitance value? So suppose total thickness of the insulated medium is D, and the dielectric slab thickness, let it is T, and its relative permittivity ER2. Now its value is T by E naught A by T by ER2 D minus T by 1, because D minus what D minus T value is thickness of the air insulating medium, then its relative permittivity 1. So we are getting that capacitance value is that. Okay, C equal to E naught A by D minus T by 1 plus T by ER2. It is the capacitance value when the new dielectric slab is placed in between the conducting plates. So now you know, if we change the dielectric material between the charged plates, capacitance value is going to be changed according to relative permittivity ER2. So if we change the dielectric material, relative permittivity is going to be changed. According to that, capacitance value is going to be changed. This is very important concept you need to understand. Okay, so while coming to the parallel plate capacitor, so if the capacitance value has to be increased, so we know that capacitance is directly proportional to area of the charged plates. If you want to increase the capacity of storing, so if you want to increase the capacitance value, so area of the plate is going to be increased. So if the area of the plate is going to be increased, the construction of the capacitor will become huge. So to avoid this disadvantage, a parallel plate capacitor has been constructed. Suppose there are 7 charged plates are there, just 1 to 7, the charged 7 charged plates are there. So all odd plates are taken and connected to a terminal 1, and all even plates are connected to terminal 2. So now the all things will act as a one plate, and these 3 plates will act as a one plate. Now, so if we see in between the plates, first 2 plates will act as one capacitor, and 2 and 3 plates will act as another capacitor. 3 and 4 will act as another capacitance. 4 and 5 will act as another capacitance. So 5 and 6 will act as another capacitance. 6 and 7 will act as another. So now if we have 7 plates, then we have got 6 capacitors. We got 6 capacitors. Now value of total capacitance equal to E naught ERA by D into N minus 1. What is N here? N is 7 here. Now we got 6 capacitors are there now. So this is the formula for parallel plate capacitors. So now factors affecting capacitance. Factors affecting capacitance. What are the various factors affecting capacitance? That is, first factor is the nature of dielectric material used. The nature of dielectric material used. So when the dielectric material is changed, we know that permittivity of that material is going to be changed. Relative permittivity. According to relative permittivity, capacitance value is going to be changed, because capacitance value is directly proportional to relative permittivity or permittivity of the dielectric material. Now, distance between the plates. If the distance between the plates is increased, capacitance value is going to be decreased. If D is decreased, capacitance will be increased. So capacitance value is inversely proportional to distance between the plates and directly proportional to area of the charged plates. So, and it is directly proportional to permittivity of the material used. So that is based on the type of dielectric material used. These are the factors that affecting the capacitance value. By changing any of these things, we can vary the capacitance value. Now, so now if we change the various parameters, what will happen to capacitance? Case 1. For the same permittivity of the material, that means dielectric material is constant. If the D is increased by 2 times and area is decreased by 2 times, the capacitance is decreased to 4 times. If area is decreased by 2 times and D is increased by 2 times, capacitance value is decreased to 4 times. Okay, if the same permittivity of the material, if D is decreased by 2 times and the area is increased by 2 times, what will happen to new capacitance? New capacitance value be increased by 4 times. It is very important point. So while coming to the next one, we said that capacitance value is directly proportional to permittivity of the dielectric used. if air medium is replaced, with mica medium in capacitance, that is a insulating material or dielectric material, now capacitance value will be increased by 6 times, because ER value for air equal to 1 and for mica ER value equal to 6. Energy stored in capacitor is given by E equal to half CV square. Energy stored in capacitor is given by E equal to half CV square joules. This means energy is stored in capacitor is in the form of voltage in electrostatic field, because E equal to half CV square. Energy stored in capacitor is in electrostatic field is in the form of voltage. It is very important point. So now types of capacitors. So types of capacitors are based on the dielectric material used. See, if air is used as a dielectric material, that is air capacitor. If paper is used as a capacitor, dielectric material, it is paper capacitor. So if plastic film capacitor, plastic film is used as insulate dielectric material, it is plastic film capacitors. And if mica is used as a dielectric material, that is mica capacitors. Based on the dielectric material used, the capacitors has been classified. So while coming to the air capacitors, so most of the air capacitors are variable capacitors. So okay, by changing the area of the plates, so by using different constructions, we will construct the variable capacitors. While coming to the paper capacitors, so paper is used as a dielectric material between charged plates. Charged plates taken, in between them the paper is placed. So now the capacitance formed is in the range between 500 picofarad to 50 microfarads, and its DC working voltage range is up to 600 volts. So paper capacitors are used up to DC working voltage 600 volts. It is very important point. And paper capacitors are designed up to 500 picofarads to 50 microfarads. It is also very important point. Well, coming to the plastic film capacitors, so that is they are manufactured in the range of 5 picofarads to 0.5 microfarads, and its DC working voltage is again 600 volts. So plastic film is replaced with paper in between the two charged plates. That is plastic film capacitor. So mica capacitor. So mica is placed between two charged plates. That is mica capacitor. So its range of manufacturing capacitance is 1 picofarad to 1 microfarad. So that is its working voltage is 35 kV around. And ceramic capacitors, these are manufactured for less than 100 picofarads of capacitance. Ceramic material use two charged plates or two electrodes are placed two sides of ceramic material. So the ceramic materials, because of its high permittivity characteristics, high capacitance can be made. Now electrolytic capacitors, it is very large value of capacitance can be manufactured by electrolytic capacitors. So it has two aluminum foils. Electrolytic capacitor has two aluminum foils, one aluminum foil with aluminum oxide. Okay, so positive terminal is always identified on body of the electrolytic capacitor. You have to identify this clearly. For a electrolytic capacitors, the positive terminal of the body is always on. Positive terminal is always identified in the body of the capacitor. So when we connecting the electrolytic capacitor, it's very important to remember that if we connect the polarities reversely, there may be a chance of explosion. So electrolytic capacitors has to be connected in correct polarity. So for that, positive terminal is identified on body of the capacitor. So while coming to the problems, so objective problems. So capacitance of two metal plates. To find out the capacitance of two metal plates, between the two metal plates, area of the plates is 30 meters square and dielectric thickness is 2 meters, and relative permittivity is 6. If electric field strength in dielectric is 500 volts per millimeter, calculate the charge on each plate. That is the bit. So capacitance value equal to E naught ER by A by D. E naught ER A by D. E naught value is, we know, 8.854 into 10 to the power minus 12. ER value 6 given, A value 30 given, and D value, thickness of the insulator, millimeters, 2 into 10 to the power of minus 3, and its value we got. And voltage across each plate is given by, okay, electric field strength into thickness of the insulating medium, that is voltage across the plates. We can calculate based on that formula. Now charge on each plate, Q equal to CV. By using that formula, we can calculate what is the charge on each plate. It is very, very important point. So now we are coming to the next. So a parallel plate capacitor has three similar parallel plates. Okay, find the ratio of capacitance when the inner plate is midway between the outers to the capacitance, when inner plate 3 times as near to the one plate as the other. So, okay, by varying the distance between the three plates, by moving the middle plate from to one side to another side, how the capacitance is changing. Okay, we have to see. Okay, this is the problem, when the how capacitance is changing by middle plate is moving when the three plates are there. Okay, when middle plate is moving towards the other plate, the capacitance value is going to be increased. If the middle plate is at middle of the line, the capacitance value is somewhat less than the near, when the plate is near. This is the another point. Well, coming to the color coding of the capacitance. So color coding of the capacitance, in this we have 5 digits. So one is A, B, D, T, V according to color. A and B first digit and second digit, and D is multiplier, T is tolerance, V yield maximum voltage level. Okay, when 4 bands are there, that is A, B, D, V. Okay, first 2 digits, and the third one is multiplier, and fourth one is voltage, maximum voltage range of that capacitance according to the values. Okay, black, brown, red, orange, yellow, green, blue, violet, gray, white, gold, silver. According to these values, A digit value table is given, B digit value table is given, and the multiplier value also given, and tolerance value for greater than 10 picofarads and less than 10 picofarads has been given. Okay, so according to this we can calculate capacitance value. I have given 2 examples of capacitance values based on this table below of the besides the color coding table. Okay, this is about color coding of the capacitance. This color coding can be calculated based on this table. We have to remember this table to calculate the capacitance value when the capacitance is given. Okay, this is about all about capacitance value. If you watch this video, you will be able to answer capacitance values. You will be able to answer the bits asked on capacitance and problems asked on capacitance. Okay, so this is all about the capacitance value. So thank you for watching, and please subscribe electrical learning track. So, and I'm going to post the next video on inductance very soon, and after that I will give you series parallel connections of resistance, inductance, capacitance, and star delta transformations of inductance, resistance, capacitance values. All these things I am going to give you in another video. Okay, thank you for watching.